All right, so this is the Unit 5 Objective 1 video on arcs and angles. A little reminder that when we are doing when the central angle is 80, the intercepted arc is also 80 degrees. And if you have an inscribed angle, which is one that touches the opposite side of the circle, it's half of it. Just if you run in the tunnel, you cut the angle in half. As you run out, you double it to get to the intercepted arc. All right, so if you look at this one, this here is the angle we're looking for, which is an inscribed angle. So as you run into the tunnel, you take half of it, so it's going to be 131. Okay? All right, so let's look at number 2. It says, solve for x given the intercepted arc. So here is, if this is 52, we are looking for this arc. Okay, that's where x is. So if this is 52 here, we have to remember this is an inscribed angle. As you run out of the tunnel, you're going to double it. So from here to here is double 52, so it is 104 degrees. Okay, and now to find angle x is I know it's going to be the sum of these two minus 360. Okay, so I take 360 minus, when I add those two together, I get 207. So that would be 153 degrees. So be 153. Obviously, this does not look like it's 52 by scale, but that's what it computed out to be. Okay, so let's look at number 3 here. So here we were given we're going to find two things. This is where y is. So we're going to solve for x and y given the inscribed angle. So this is an inscribed angle. It's not the central angle. So when I come out, it's going to double. So that's going to be 104. If I double 52, I get 104 degrees. Now if I look at angle x, that's a central angle, so it will be the same. So x is 104. Okay. Now we're going to go find angle y. Well, again, I know this is 104, this is 125. So if I add those two together, I get it's 360 minus what? 229, which gives me 131 degrees. Okay? So we solve for x and y. All right, so let's go look down here at number 4, and we're going to solve for x. So I want you to remember is this arc is not 110. Okay, if we want to remember that if I can always draw that in, and that angle gets bigger by how much? By twice, so that central angle is 2 times this, which is 220. So now the central angle and this arc are the same. So I'm going to do 220 is equal to 6x plus 8. Okay. I'm going to subtract 8 then, subtract 8, and I get 222, no, I'm sorry, 212 is equal to 6x. If I divide by 6, calculator right here, just to check it, 212 divided by 6, and I get 35.3 repeating. Okay? All right, so let's go on to number 5. 2 ways to look at number 5 here is this angle here is going to be half of this one because you run in the tunnel, you take half of it. So you could say then that 4x is not going to equal 100. It's actually going to equal half of that angle, so it's 50. If I divide it by 4, I get x is 12.5. Okay? All right. So now our last one we're going to do, you could have, by the way, taken half of this one. Nope, never mind. All right, so let's go ahead and look at number 6. All right, so we're going to solve for x and y on the last one. All right, so first of all, y is this angle right here. I want to find out how much that arc is. Well, if this is 62, is that the same? No, it is not. It's going to double on its way out. So y value is 124, which is 62 times 2. Okay, now I need to find the value of x. Well, since this angle covers the same intercepted arc, I'm just going to do x minus 8 is equal to 62. I add 8 to both sides, and x is going to be 70. Okay? So really, we only have a couple concepts in here, and that's the relationship between the central angle and the intercepted arc, and what the relationship is between the intercepted arc and the inscribed angle and the central angle. Okay? And then the other thing is the total angles of a circle are 360. Okay, I hope this helps, and that'll be the first video. Thank you.